So for our warm-up today, we're going to go ahead and practice finding the x-intercepts of our polynomials. So taking a look at this first one, our a is 6. It is our coefficient of our x squared. Our b is 5. It's the coefficient of our plane x. And our c is our constant, which is -6. Now we're going to go ahead and put this into our diamond problem. A times C, -36, is going to go up top, and our B is going to go down below, be bottom. Now we're going to go ahead and find two numbers that multiply to -36 and add to 5. So we have 1 times 36, which are either 37 or 35. We have 2 times 18, which is 20 or 16. I then am going to pull out my calculator so I don't miss any of those. So I'm going to go 36 divided by 3, which is 3 times 12, which is 15 or 9. I'm looking for a 5. We have 36 divided by 4, which is 4 times 9, which is 13 or 5. And that's what I'm looking for is a 5. So I'm going to break this down into a 4 and a 9. I want a positive 5. So that's going to be 9 minus 4. Now we're going to go ahead and take this information and we're going to embed it into our generic rectangle. Our 6x squared goes in the bottom left. Our constant -6 goes in the upper right. And we're breaking that 5x down into 9x and -4x. Now we're ready to go ahead and factor the generic rectangle and find the outsides. In this direction, I see that my smallest number is a 6, but it doesn't go evenly into 9. But I know 3 goes evenly into both 6 and 9, so I can take a 3x going this direction. I know that 3x times 2x gives me 6x squared. I know to turn a 2x into a -4x, I multiply by -2. And to turn a 3x into a 9x, I multiply by 3. So my product form is 3x minus 2 times 2x plus 3. Now we're going to finish up by using the zero product property, and we're setting them both equal to 0 in solving. So I have 3x minus 2 equals 0, and 2x plus 3 equals 0. This first one, I'm going to add 2 to both sides, and I have 3x is equal to 2. Divide both sides by 3, and my first root, x, is going to be 2/3. Okay. For my second one here, I'm going to subtract 3 from both sides. That gives me 2x is equal to -3. Divide both sides by 2. And so my second root is going to be -1.5. You can also leave that as -3/2. For me, I like to leave anything that is a repeater, like 2/3 is a fraction. And if it is a terminating decimal, I do prefer to leave that as a decimal. So now we're going to double check this to make sure that we are correct. So we're going to go ahead and type in our parabola, our equation in standard form. 6x squared plus 5x minus 6. And then we're going to go ahead and click on our roots. We have our first one at -1.5 and our second one at 0.667, which is the decimal equivalent of 2/3. Excellent. Let's go ahead and move on to problem number 2. Here we have 8x squared minus 50. And so I can see that they are both even. So I'm going to rewrite it first by pulling that 2 out. So 8 divided by 2 gives me 4x squared. And then I have -50 divided by 2, which is -25. And that just gives me easier numbers here to look at. And I have to remember that 2 at the end. It's not going to change my roots, but it will change my vertex later. So my A is 4, my B is 0 because there is no x, and my C is -25. Now, whenever we have one of these for our diamond problems, 4 times -25 is -100, and B is 0. When we have that 0 down below, that means the right and the left are going to be perfect squares. And I know the square root of 100 is going to be 10. So I'm going to have one 10 and one -10. And that's because these two have to be opposites in order to add or combine together to be 0. So now we're going to go ahead and put that over into our generic rectangle. We have our 4x squared, our negative 25, and then our middle term, which is 0, is broken up into 10x minus 10x. Now I see that 2 is divisible by both sides, so it's going to be a 2x and a 2x. 2x times negative 5 is going to give me a negative 10x, and 2x times positive 5 is going to give me that positive 10x. So we have 2x minus 5 times 2x plus 5. Okay, we're now going to set both of those equal to 0 and solve. So I'm going to add 5 to both sides, and I have 2x is equal to 5. Divide both sides by 2, and x is equal to 2.5 or 2.5. For the second one, I'm going to subtract 5 from both sides. 2x is equal to negative 5. Divide both sides by 2, and I have x is equal to negative 2.5. Okay, so whenever we have this, it's a special situation. And for this type of a parabola, that means that my vertex is going to be at 0. So 8x squared minus 50. And that means because my vertex is at 0, that these are going to be opposites of each other. So once again, one root at negative 2.5 and my other root at positive 2.5. It's a long, skinny guy because we do have that vertex at that negative 50. Okay, let's go ahead and move on to problem number 3. So I have a couple things that I need to take out first. Notice that they're all divisible by 2, but I have extra x's in. I have x's in all of them, so I'm actually going to take out 2x. So what I have left here is x squared, and then here I have plus x, and then I have 112 divided by 2. We're going to just do that so we're not wrong. We want to double check our work. So negative 112 divided by 2 gives me negative 56. So I rewrite my equation as 2x times the quantity, x squared plus x minus 56. So that gives me an a of 1, a b of 1, and a c of negative 56. So I'm ready to go ahead and put that into my diamond problem. Negative 56 times 1 is negative 56, and our b goes on the bottom. So I'm looking for those factors. Whenever this is a small number down below, I know they're going to be close to each other. So I have 1 times 56. That doesn't make a 1. 2 times, let's go 56 divided by 2. That gives me 28. That makes a 30 or a 26. 56 divided by 3 doesn't go evenly. 56 divided by 4 is 4 times 14. I'm looking for a 1. That's, again, an 18 or a 10. 56 divided by 5 doesn't work. Divided by 6 doesn't work. Divided by 7 is 8. Ding, ding, ding. 7 times 8 adds to 15, subtracts to 1. So whenever it has a 1 down below, you're going to have two numbers that are really close to each other. So we have a 7 and an 8. It's a positive 1, so that's going to be 8 minus 7. Let's go ahead and put that into our generic rectangle. And we have a this one over here, x squared, and a negative 56, an 8x, and a negative 7x. The only way we get an x squared is x times x. So we're going to have a negative 7 here and a positive 8 here. And so we have, as product form, we can't forget, and actually this one up above, we need to have our 2 out there as well, because that will affect it when we find our vertex. But we have 2x times the quantity, x minus 7 times x plus 8. So when we have the 0 product property, we actually have to set all of them equal to 0 that have x's, and our 2x does. So we actually have 3 here. We have 2x is equal to 0, x minus 7 is equal to 0, and x plus 8 is equal to 0. This one, we're going to divide both sides by 2, and our first x is going to be 0. This one, we're going to add 7 to both sides, and so x is going to be 7. And our last one here, subtract 8 from both sides, and so we have x is equal to negative 8, and that's a positive 7. Okay, so we're going to go ahead. We have 3 roots, and that's because an x cubed looks like this. And so let's go ahead and take a look at those roots on Desmos to verify. So we have, and we'll type in the original equation, 2x to the third power plus 2x squared minus 112x. So if I zoom out, you can kind of see how that curve is looking there. It's like a doot. It's really tight though. And so we're going to take a look at those three roots. So my first root is at -8. My second root is at 0. And my third root is at 7. So once again, an x cubed potentially, not always, can have 3 of those. Okay, our very last one here is another special equation where we have 9x squared minus 24x plus 16. And I don't need to rewrite it. I don't have a number that will go evenly into all three. So I have a 9 for A, a -24 for B, and a 16 for C. So we're going to go ahead and multiply 16 times 9 for my top number, and that's 144, and -24 on my bottom. So now I'm going to go ahead and look for those factors. 1 times 144 is not going to do it. 144 divided by 2 is 2 times 72. That's 74, 70. 144 divided by 3 is 3 times 48, and that's 51. 144 divided by 4 is 36. We're getting closer. 144 divided by 5 doesn't work. Divided by 6 is 6 times 24, which is 30 or 18. 144 divided by 7 doesn't work. Divided by 8 is 8 times 18, and that's 26 or 10. 144 divided by 9 is 16. 9 times 16, and that one is 25 or 7. So we have 144 divided by 10 doesn't work, divided by 11 doesn't work, but 12 does. 12 times 12 is 24 when we add it. So that took a long time, but I like to go in order so that when I get there, I know I didn't miss it. So we have a 12 and a 12. It needs to be -144, a positive 144, but a -24, so they're both going to be negative. Now we're going to go ahead and plug that into our generic rectangle. We have our 9x squared in the bottom left, our 16 in the upper right, and then we're going to plug our -24 into a -12x and a -12x. So we're going to go ahead and take out a 3x going in this direction, which makes this one a 3x. 3x times -4 is -12x, and 3x minus 4 is -12x. So as we're putting this into product form, it's 3x minus 4 times 3x minus 4. However, a mathematician would write that as 3x minus 4 squared, with the base being the same and multiplying by itself twice. Now, what this means is there's only one root, and that root is going to be on the vertex. So we're just going to set our one number equal to 0. We're going to add 4 to both sides. And we are going to get 3x is equal to 4, divide both sides by 3, and our x is equal to 4/3, which of course is the same as 1 1/3 or 1.333. Let's go ahead and take a look at that one to verify. And once again, this is another special circumstance, 9x squared. And this one is called the perfect square trinomial. B that we solved is a difference of squares. And so these are special circumstances that you'll run into. And if you can memorize that pattern, it actually makes them much easier to solve. And you'll be working on that in Algebra 2. So as you can see, here we have a single vertex, and that, of course, is at 1.333. So a lot of work in our warm-up today, ladies and gentlemen, as you can see, and that's because parabolas are the heart of algebra. And if you can successfully solve these types of problems, then you're in a very positive situation where I know that you're going to be successful in Algebra 2.